We're going to start trigonometry and right triangle trigonometry. Trigonometry is a great class because you can kind of start anywhere in trigonometry and then just work your way out. I prefer to start in right triangle trigonometry, probably because that's where I started when I was learning trigonometry. And so I'm just subjecting my trauma onto you. I mean, just using the techniques that were used with me with you. So I happen to like right triangle trigonometry. If you're a unit circle type person, then you know the difference between the two. Why are you in the class? You should be like teaching the class or something. But anyway, let's talk about right triangle. A right triangle is just a triangle with a right angle. One of the angles is a right angle. I usually draw my right triangles like ramps from left to right. This is probably because my first language is English and we read from left to right. And my favorite TV show when I was a kid was Dukes of Hazzard and Knight Rider, where cars make jumps. And the jumps just usually went left to right. So this is how I draw my right triangle. All we want to do today is to note that there are two things that we know about right triangles. One of them is something that we know about all triangles. The sum of the angles in any triangle is 180 degrees. The sum of the angles in any triangle is 180 degrees. That means in a right triangle, the sum of the acute angles is 90 degrees. Because we use 90 degrees in the right angle, 180 minus 90 leaves 90 to be distributed amongst the other two acute angles. What does acute angle mean? What is acute? Acute just means less than 90. Perfect. See, y'all know so much stuff already. So here's something we know about the angles in a triangle. When we're dealing with right triangles, there's something else, something we know about the sides, a relationship between the sides of a right triangle. And I'm going to guess that we know what it is. You might not know what I'm talking about right now, but as soon as someone says it, you will. What's something that relates the sides of a right triangle? It's an old Greek thing. The Pythagorean Theorem states a relationship between the three sides of a right triangle. I called it an old Greek thing, but it was an old result by the time the Greeks called it the Pythagorean Theorem. The way I picture it is Pythagoras was like all standing with a bunch of his students or his disciples, whatever you want to call them. And he's like, oh, the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. And his students were like, or disciples were like, oh, man, that's pretty cool. Did you come up with that? And Pythagoras was like, oh, you never heard of that before? And his students or disciples were like, oh, no. It's like, oh, then yeah, I came up with that. That's my theorem. It's the Pythagorean theorem named for me, Joe Pythagoras. I don't know what his first name was. I don't think they had first names and stuff like that. So the Pythagorean theorem in words is kind of a pain in the butt. The sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. The sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. What's the hypotenuse? Does anybody know what the hypotenuse is? It's the biggest side. And where's the biggest side going to be? Opposite the right angle. So the hypotenuse is the name for the side opposite the right angle. Hypotenuse is the side opposite the right angle. We know there's only going to be one because the sum of the angles in a triangle is 180 degrees. I didn't prove that. I just hope that you would all believe me. So we can only have one right angle in a triangle because you've got to have triangles. And if I use 90 degrees up in one, I've only got 90 degrees left. I can't fit another right angle in my triangle in Euclidean geometry. But that's what the trigonometry, that's the world we're living in. We're living in Euclidean trigonometry, geometry. Now, unfortunately for Pythagoras, they didn't have algebra. I know we think algebra is like old and silly, but they didn't have the power of algebra, and we do. How do we normally state the Pythagorean theorem? A squared plus b squared equals c squared. How many people remember a squared plus b squared equals c squared? More than that. So I should say, how many people don't remember a squared plus b squared equals c squared? Then you don't have to raise your hand. Right? So if I'm like, oh, how many people know? Raise your hand if you know what 2 plus 3 is equal to. Right? No one. But now if I ask the opposite question, I can play into your strength and your desire to not raise your hand. And I can go, does anybody not know what 2 plus 3 is? See, everybody knows what 2 plus 3 is. Because no one wants to raise their hand because that's not cool. I'm not raising my hand because some teacher asked me to. But it does become the Joker test. I'm like, well, does anybody not know what 2 plus 3 is equal to? I don't know what 2 plus 3 is. That's when that student finds out not to mess. I'm like, well, you should get out. You're not qualified to be in here. You know, I was just kidding. So get out. I go, no, I was just kidding. I said, get out. I'm just kidding. I never stabbed a student from me. I tried to claim that he knows 2 plus 3. Threw out the window. I'm just kidding. The windows don't open. And I'm not throwing someone through a window that I have to pay for. I threw him out the door. I'm just kidding. I didn't throw him out the door. It's more of a drag. I'm just kidding. I didn't drag him. I never did that. So normally we write for the Pythagorean theorem, a squared plus b squared equals c squared. This does require that we put c in the right spot. A and b can be either of the legs, but c has to be the hypotenuse. But thanks to algebra, we have a better way. Oops, I usually put a up here. We have a more convenient way of remembering the Pythagorean theorem. A squared plus b squared equals c squared. All we have to do in addition to that is remember that c is the hypotenuse, a and b are whatever legs we want them to be. The Pythagorean theorem is something about the sides in a right triangle. The sum of the angles thing, that's about the angles in a right triangle. We need something that connects the two. We need some connection between the sides and the angles. And that's where trigonometry enters. Trigonometric functions connect the sides and the angles. It's trigonometric functions that are going to connect sides and angles. We're going to define our favorite three trig functions in a right triangle. For this, I don't need A, B, and C and all that, but I don't need alpha, beta, and gamma. I just need to focus on one angle. And then we'll just extrapolate from there. I'm going to say this angle down here is going to be called theta. In this right triangle, the hypotenuse is always where the hypotenuse is going to be, opposite the right angle. Once I pick one of the angles and call it theta, I can say over here is the side opposite theta. And then down here at the bottom, does anyone know what I'm going to call this? Maybe you saw the preview. We gave it away in the trailers. So I use the words opposite and adjacent. Those are relative to a defined angle. You have opposite theta and adjacent to theta. So the three sides of the triangle are opposites, adjacent, and hypotenuse. And with these names, we can define our trig function, which will be our last thing today. Our three favorite trig functions are sine, cosine, and tangent. The thing that we have to remember is that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Notice that these relationships are between an angle in the right triangle and sides in the right triangle. So now if we have sides and angle information, now we can figure out some more stuff about the triangle. Is everybody okay? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. There are lots of mnemonic devices for remembering these. Some people just remember sine, cosine, tangent. They just OH, AH, and AA, OA. So they go, oh heck, another hour of algebra. Some people have to have the sign. So SOH, CAHTOA. So SOHCAHTOA. My personal favorite mnemonic device for remembering these three is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. The most common one, if you've heard of one of these before, is probably SOHCAHTOA. When there's a nice warm bath, you want to go up and you want to SOHCAHTOA in the bath. I'm really glad that that one came up. A student suggested that one a couple of years ago because I learned trigonometry back in the 80s. And let's just say that when I was taught SOHCAHTOA, it was a bit racist. And we're trying to be better than that. You know what I mean? I'm not even going to go into it. I like that teacher, but I called him up 30 years later. I'm like, oh, dude, seriously? That's so. But he was an old man at that point. He was like, I don't know what you're talking about. Then he went back to yelling at the cloud. Any questions? All you have to do over the weekend is jump on the canvas, poke around a little bit, start to figure some stuff out, maybe start homework from section 1.1. But definitely by next week on Tuesday, you will know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So if I ask you what cosine is, you have to say adjacent over hypotenuse without looking anything up. And you will have 5 seconds to do it. In unison, and I prefer harmony. To keep things light, major harmony, please. First, third, and fifth. I'm just kidding. You don't have to sing it. You're not in my high school class. The other thing that I want you to remember, running in the background, more important than just this, is that the context that this is sitting, this is giving us a relationship between angles and sides. Pythagorean theorem, all sides. That's just a side thing. I mean, it's like a main thing, but it's like a side thing. It's about the side. The angle, some of the angles are 180 degrees. That's all just about the angle. That's all angles. This combines the two, sides and angles, but only in right triangles. So that's a limitation that we have. Any questions? Comments? Snide remarks? Of course not. It's friggin' 2:30 and I'm using my wrap-up voice. No one's going to ask me anything because it'll prolong class and everybody else will be mad at you. So That's it for today. That's it for this week. I'll see you all on Tuesday. Everybody have a good weekend and thanks for playing.